to KeySmash Studios tutorial. In this video, I'm going to be showing you how to create animations using UCurveFloats. In between videos, I went ahead and added in the models that we're going to be animating, which is an axe, a pickaxe, and a fishing pole, and I added them into the scene and attached them to our character. I did this off camera because I didn't want the video to focus on the importing of the items, but the animating of these items. However, before we get into it, I did want to point out a few things I did for these items so that way you can be at the same stage that I am. So over in my details panel, if I click on all of these and type in hidden, you can see that I've checked off actor hidden in game, and I did this so that way the objects wouldn't be visible whenever we click play, as I only want them to appear when they're being animated in the designated interaction areas. I also made them movable, so if you look at the transform, you can see that they're all movable. This is so that they are able to move with the player. And again, I attached them as children to the character, so that way when the character moves, these objects will move with it. And that's all I wanted to cover before we actually get into what we're doing in this video. So as you're watching, if you find this video helpful, please remember to like and subscribe. So the first thing we want to do is actually create our curve. So we're going to go down to our content browser. We're going to go up to miscellaneous, and then we're going to go to curve. We want this to be a curve float, and I'm going to name it fishing anim. And as you can see over to the side of this, I have actually already done the axe animation, and I'm going to use the axe animation for both the pickaxe and the regular axe, as I want them to animate in the same form. Both will just be going in a chop motion. However, with our fishing pole, I don't want it to go in a chop motion. I want it to cast out and then sit for a second and then reel back in. So I'm going to use the fishing animation to show you how to use the curve, and then I'll show you what I did for the axe animation once we're done with that. So we'll go ahead and open this. And you're going to want your point to start at 0, 0, and the way you add a point is by going over the line and then clicking the middle mouse button. So I'm going to have 4 points for this. I'm going to have the start point, which is 0, 0. Then I'm going to have a point for us casting the rod. It's going to be a flat line between casting and then reeling, and reeling will be that third point. And then I want it to go back to its initial stage, so that will be the fourth point. So for our first point, which will be where it's casted, I'm going to go down and add the point at 1. And I'm actually doing it in the negative direction, simply because of the way my model imported forward in relation to the player is negative in the roll direction for my fishing rod. So you may end up having to play around with your tools to see if you need to go in a positive rotation or a negative rotation. So I'm going to add a point here, and you have to add it on the line, and then I'm going to drag it down to 1. And then as you can see, you can also change the key by typing in your value up here. So this is 0.5 across and -1 down. I also have on my snapping, which is why it's exact, but if you don't have on your snapping, then it may be like 0.54 or -0.9. So if you're wanting an exact number and don't have on snapping, you can do that inside of these value boxes. So now I'm going to go ahead and do my next point, and I'm going to do that around 2.5. And I'm going to leave that one where it is at the -1, and then I'm going to add my final point at the 3 value. And the reason I'm doing 3 is because inside of our script, we created a delay, and that's how long you interact with something, and we made that delay 3 seconds. So I want this animation to last 3 seconds. But I do want this to go back to 0, in other words, the original rotation of my object. And as you can see, we go from 0 to 1 in value, 1 being the goal rotation that we end up passing this through the code. So these values aren't relevant to the total rotation that you go. I'm not going 1 degree difference. I'm going 1 times the goal rotation value that I pass in. So that's all we have to do for this curve. Again, you use the middle mouse button to add points. And another thing that I want to do before we finish this is actually have it be curved in the beginning. So if you go up here, you have different types of curves that you can have, and I want mine to be an automatic curve. So I'm going to click on this first point and then click automatic. And then as you can see, it makes it more curved and not just a linear line. So that way it starts off slow and picks up speed and then slows back down again towards the end of that specific movement. I'm going to leave the other line linear so that way it's a constant movement for the reeling in. But now I can go ahead and save this, and I'll go back to the scene and go ahead and show you my axe animation. So again, we go from 0 to 3. My axe and pickaxe model imported in the opposite direction of my fishing rod, so I was able to go in the positive direction for this one. And this just creates a chop animation, so it goes up to that max rotation that I pass it, and then it goes back to its original rotation. back up to the max, and then back down to the original at 3 seconds. I'm able to use this curve for both my axe and pickaxe animations because both of them are only 3 seconds long. However, if you have different delays per interaction, you're going to need a different curve for each of those interactions that match the same time as your delay. But that's all we're doing with our curves, so now we can go ahead and go to our code. And we're going to open back up the My Character script. And we're going to start off in our header. And the first thing we're going to do is add another including. And this include is going to be for handling the timeline of our curves. So it's going to be components /timeline component.h. And then we're going to add another argument for our canInteract function. And we're adding this property because we need a way to handle the indexes of our T arrays that we'll create for both the tools and the 3 different curve floats. We're going to do int I, and then we're also going to need to create a U property for this class that can hold a reference to that value for us. So we'll come down here with our other ones and do U property int type index. And again, this is going to be used for whenever we're animating our object, so that way we can say the type of interaction area we're inside and which tool we need to set active. And now we can go ahead and create a function. This needs to be a U function, as it's going to be bound to our timeline, and the argument that the binding of the timeline takes in is a U function. So it's going to be void, and I'm going to call it animate. And then it also needs to take in a float value, so that way we can go from the initial rotation to our goal rotation over time. And next is going to be our U properties. Our first U property is going to be our tools, so we want it to be edit anywhere, so that way we can add these in our details panel. And then I'm going to give it a category so we can find it easier, called animations. And this is going to be a T array of a actor pointers, and I'm just going to call it tools. Our next property is going to be for our curves. So again, edit anywhere, as we want to be able to set these in the details panel, and a category of animations, so that way we can find the tools and the U curves together. And this is going to be another T array, UCurveFloat. Again, pointers. And we're going to call this tool anims. And then I need to go back and change these. There we go. And then we're actually going to have 3 more properties to handle the rotation for this curve float. So the first one is going to be a timeline. So it's F timeline, and I'm just going to call it timeline. And then our next one is going to be a F rotator for our initial rotation, so that way we know what to go back to. And then finally, we're going to do another F rotator for our final rotation, which will be our goal rotation. And now that we're done with our header, we can go over to our CPP, and we're going to start with our canInteract function. And then we'll just go through all of the interaction functions one by one to add in the new handling for our animations. So to start off with our canInteract, we need to add in this argument that we've created of int I, and then we need to assign that int I to our type index. So type index equals I. And again, we're doing this so that way we can access this value of I outside of our canInteract function. And the next thing we want to do is make sure that the curve that we're wanting to use for our animation was properly added to our T array. So the way we do that is by checking if the address of our tool anim at the index of type index is not null, which is what this if statement is doing. Sorry, it's tool anims. And once we know that this is not null, then we can go ahead and do f on timeline float. And we're going to call this animation. And this is what we're going to use to bind our curve with our function of animate. So we're going to do animation dot bind UFunction. And we're binding it to this class. And then the name of the function that we're binding it to is animate. And then we want to take our timeline, and then we're going to add interp float. And the curve that we want our timeline to be using is going to be tool anims at type index. That we've checked is not null, so that way we don't get any errors here if we try to use it and forgot to add it to our TRA. And then the function that we want to use is the animation one that we have bound to our animate function. And then finally, I'm going to do timeline set looping, and I'm going to set this to false, as I don't want my timeline to continuously loop. I want it to go once and then stop while our player is interacting with the area. So that's everything for can interact. So now we can go down to our interact function. And I'm actually going to comment out these debug messages, as now we'll easily be able to tell when things are happening because we'll have animations to show us. We want to get that initial rotation of our tool, and then we want to set that goal rotation for that tool. So I'm going to do initial rotation equals the tool of the type index, in other words, the one that we're currently interacting with. And then I want to get this actor's rotation. And then what I want to do is go ahead and set that goal rotation as well. And I'm going to set it to the initial rotation for simplicity, and then the only rotating that I want to happen is in the roll direction. So I'm going to do goal rotation dot roll, and I'm going to plus equals 60 to it. I'm using a rotation of 60 in the roll direction for all of my tools. You may want to create an if statement here to determine which tool you're currently using if you're wanting different rotations per tool. However, a rotation of 60 in the roll works for all of mine, so I'm just doing that for simplicity. And now that we've done that, we can go ahead and play our animation. So the first thing we want to make sure is that our timeline isn't currently playing. So the way we do that is by not timeline.isPlaying. And then if it's not playing, we want to go ahead and take our object and make it visible in the scene. So we're going to do type index dot set actor hidden in game to false. And then after that, we can go ahead and take our timeline and play from start. And that's everything for our interact function. We get the rotations we want. We make sure that an animation isn't already playing. If it's not, then we go ahead and set our tool visible in the scene and start the animation. Now we can go ahead and go down to our collect from area. And we just want to do one thing here. After we're done collecting our stuff, we want to make it to where the tool isn't visible again. So we're going to do tools, type index, set actor hidden in scene, hidden in game to true. And that's all the code that we're adding to our collection functions. So now we can go ahead and just go up to the top, and we're going to add our animate function. So void aMyCharacter animate, and then our parameter was float value. Inside here, what we're wanting to do is rotate our object based off that curve. So we're going to need an F rotator, and we'll just call it rot. And we want to lerp it so that way it's a smooth rotation. So we're going to do F math lerp, and then the arguments for this is our initial rotation, our goal rotation, and then finally the value that we want it to progressively rotate by, which is just the value that we take in for our animate function. And then finally we want to take the tool that we currently are using, so tools type index, and then we want to set the actor's rotation to the rotate value that's returned from our lerp. And now we have one final line of code, so we're going to go up to our tick function, because we need that animate function to be called each frame when we're interacting. And so the way we do this is by doing timeline, and then tick timeline, and then inside this we want our delta time. This delta time is going to be the value that is passed to that animate function, so that way we can have a smooth transition from our initial rotation to our goal rotation. And what this line is essentially doing is checking if we're using our timeline. In other words, is it playing? And if it is playing, then it's going to call on the bound function, which is animate, with the value of delta time passed to it. So we can go ahead and save. And this is all we're going to be doing to our my character script, but we do have a few things to add to our interaction area now. So we'll go ahead and go over to our interaction.h, and we're going to add a U property. We want this one to also be edit anywhere, just like our other ones, so that way we can edit it in the details panel. And this is going to be our int type index. This is so that way we can say if it's a tree interaction area, it's an index of 0, a mining interaction area is an index of 1, and a fishing interaction area is an index of 2. So that way we can use the correct tool and curve in our character class while we're interacting with these areas. So that's all for our header. So now we can go to our CPP. And what we want to do here is add in that new parameter for our can interact functions. So when we enter the area, we want that to be the type index. And then inside of our exit area, we're just going to give it a 0 to keep it as an equivalent of null. Obviously, in this case, 0 actually represents our first index, but we're not using it to determine if we're in an area like we are with the area type and area item. So we're just going to leave it as 0. And that's all of the coding for this tutorial. So we can go back to the scene and compile our code. And now that our code is compiled, we want to go ahead and add values to these new properties. So the first thing is our character. We've added 2 new properties, and we want 3 elements inside of both of these T arrays. And the first one is our tools, so we want our axe to be 1, as I'm going to end up doing the trees to be index 0. We want our 1 to be the pickaxe, as I'm going to do the stones at index 1. And then finally, we're going to do our fishing rod. I'm going to make the interaction areas for the ponds be at index 2. And again, to tie in the importance, we need the index of our tools and the index of our tool animations to be the same index that we end up giving to our interaction areas. So for our tool animations, I'm going to do the axe animation for both the first 2. And then I'm going to do the fishing rod animation for the final one. And now we need to go to our interaction areas and go ahead and give them that new index value. So here we're looking for this type index. My fishing is going to be an index of 2. My stones are going to be an index of 1. And then my trees should be defaulted to an index of 0, so they're good. So now I'm going to go ahead and save, and we can test and play. And it's not animating, so 1 second, let me look at this. My tick is good. It looks like I misspelled animate for my function, but I'm just going to misspell it as well inside of my bind, and that should fix the issue. So I'm just going to compile again. Now let's test it out again. So now if I go over to this tree and click F to chop, it does in fact show the animation. If I go over to my rock, it does in fact show and switch to the correct tool and show the chopping animation for that one. And now we can go fishing. As you can see, it goes out and then comes back in. So as a recap, we used Unreal's UCurveFloats and timeline to create a way to animate our tools for our game. As always, I hope this video was helpful. If you have any questions or suggestions, feel free to leave them in the comments, or you can join our Discord and ask them there. We do videos here every Wednesday and Saturday, but we also stream on Twitch, so be sure to check us out there. We've created a game on the Google Play Store called Blast Off, and we've created an asset pack on the Unity store of kids' toys. And we've also recently started up a Patreon. If any of those things interest you, or you would like to support us in any of those ways, the link to all of those things will be in the description below. Don't forget to like and subscribe. Thanks for watching. See you next time.